Y'all took cover under your desk. I'm proud of you all. Okay, so let's talk about this. We're doing this. Okay. Identify all the information in the problem. So population mean and a chi-square, does that apply? It doesn't apply. Standard deviation, does it apply? No. Does sample mean and proportion apply? Perhaps, but I'm not going to worry about it. N, what's my N? That one actually does apply. Although I gave it to you. It should be 8474. Let's see if I did it right. So if I do the sum of this whole table, hopefully it is 8474. Okay, that one applies. Alpha applies. Okay. So that was actually fairly easy. Most of this stuff doesn't apply. Okay? All right. Are the data quantitative or categorical? Categorical. What are the categories, by the way? Actually, I would say low, anger, moderate, and high. Your groups would be heart disease and no heart disease. Okay? What's the null and the alternative hypothesis? Say it again. CHD independent of anger. And your alternative? CHD not independent of anger. Okay. What type of test? Don't call it a chi-square. We're not Chinese, we're Greek. Okay, chi-square test of independence. What is the p-value? Okay, so now I need to do all my tests. So part D was a lot bigger than just answering that question. Okay, so what do? I'm going to copy the table. I'm going to paste it. I'm going to erase all the numbers. What is this one going to be called? This is my expected. And this one is my observed minus expected, right? All right. So now what? I need all the totals, right? Totals. So I'm going to auto sum that. I'm going to auto sum that. I'm going to auto sum all of these. In fact, rather than do it this way, I'm going to copy and paste. Okay? Maybe I'll center them so they look okay. Okay? All right, now what? How do I find this value here? Equals row 1 total times column 1 total divided by the grand total. Okay? Equals row 2 times column 1 divided by the grand. The next one. Okay, yeah, this one you don't need parentheses on. This one is what? Make it bigger. If I do, it's going to go off the screen and then you won't be able to see. Here, I can move this up here though. Let's do this. Okay, that'll help. Okay, where am I at? I'm on row 1 times column 2 divided by the grand equals row 2 times column 2 divided by the grand equals row 1 times column 3 divided by the grand equals row 2 times column 3 divided by the grand. Okay? Let's move this up here. Maybe that'll help. Okay? All right, now what? Okay, and does this one need parentheses? Sure does. Equals the observed minus the expected squared divided by the expected. Okay, now, let me ask you a question. Can I copy this formula? This one I can just copy. So I'm going to go down one, I'm going to go over 3, and that one works. Can you copy these formulas? No. I'll answer it. You can if you're an Excel expert, but it's too hard and I'm not going to worry about it. So don't copy those, but you can copy these. Okay? So, but yeah, this table here, you're going to have to find all of those manually. Okay? This table here, you just find the first one, then you copy the formula and it works fine. Okay? If you did the first one right. Okay? All right, now what do? Find the sum. And the sum of this entire table, right? Okay? So I got a value of 16.078. Okay? Now I'm trying to decide, so this is a good idea. So this comes up to Laura's question about critical values. Okay? So how does the critical value apply? So I got a value of 16.078. So how to decide, is that in the critical region or not? Okay? Now this is not what I taught you the other day, but it was on Khan Academy, and there's nothing wrong with this other than the fact that in real life nobody uses this. It is a good learning tool for students, and if you like it, that's fine. I still want to know what the p-value is. Do the p-value? Okay, so we'll do the p-value. Here's what I will say. There are some students that like they refer to this as the classical method. Some of you will like this better, and I have no problem with you doing it. I just want the p-value also. So how do I find the p-value? Let's do the p-value first. Yeah, what's my degrees of freedom? My degrees of freedom in this case is 2, right? Okay, I will need that also for the critical value method. Okay, so my p-value is going to be equals what? And I think I forgot to show you guys how to do this with a table. Oh, I should have. Oh, okay. Okay, so we'll do that too. All right, here we go. So your p-value equals what? Chi-squared dist, which one? The right-tailed. Okay, what do I put in for x? 16.07. My degrees of freedom, 2. I got a value of 0.0032. Okay? So this says reject or do not reject. Reject the null. In here? It's just those 2 values right there. The 16 and the degrees of freedom 2. Okay? All right, so we're rejecting the null, and the conclusion is CHD is not independent of anger. Okay, and then the extra credit says which one is most out of whack, basically. Okay, now as you look at these, so we're saying that, okay, so let's go back to my sum here, okay? Which of these numbers here contributes most to the sum? The 11 does, right? So we're looking at high anger and CHD here. Okay, so let's look at this for a minute. So the high anger people, if they were independent, we would have expected 14 people to have coronary heart disease. We got 27. We got twice as many people with coronary heart disease that have high anger issues. That's a lot higher, right? That's twice as much. Okay, so the extra credit is people with high anger have more coronary heart disease than expected. What's the next biggest number out of these numbers here? The low anger. Well, let's see what's going on with the low anger people. We would have expected 69.7 people to get coronary heart disease. we only got 53. People with low anger have less coronary heart disease than expected. Okay, does this sound meaningful to you? If you want to die from coronary heart disease, get angry. If you want to not die from it, don't get angry. Okay? So you could keep going, but those are kind of the two biggest ones. That's probably where I would stop, and I would say, now, by the way, let's look at this one really quickly. This is the smallest number, right? So moderate anger people. So we expected 4624. We got 4621. That's like right on the money. Okay, so that's basically what you would have expected, which is why this is the smallest value. So if you've got moderate anger, yeah, it doesn't really play much of a role in coronary heart disease. Does that make sense? Does that make sense? Okay. Helena.
So, what is rejected or not rejected? I had it saying you reject it if the sum is large.
The sum is large. Okay, so here's what I mean. Okay, and this kind of goes back to Laura's question about critical values. So yeah, so how do you decide if this is large? Okay, so let's go back to, and this relates to critical values, okay? So the idea here is, let's go to my chi-square table. Am I sharing this? Have I not been sharing this the whole time? Oh, that's terrible. I haven't been sharing. I've been doing all this stuff without sharing. Okay, there it is for everybody to see. I'll try to put that in sooner. Okay, so there's all your calculations. So the question is 16 large? Okay, and this relates to the critical value method. Okay, so the idea here is if I go here to my table here, I want my alpha is 0.05, right? I've got 2 degrees of freedom. What's my critical value here? It's 5.991. So let me show you what's going on here. Okay, I'm going to erase this. Okay, so the idea here is I've got a chi-square distribution. It's going to be strongly skewed to the right. Okay, so what I've done here, so I found that value 5.991. What I'm saying here, 5.991, this area is my rejection region. If I get a value higher than 5.991, I'm going to reject. What value did I get? I got 16. I'm way out here in the tail. Let's continue on out here like this, okay? So, using the classical method, is my sum large? Yeah, 16 is much larger than 5.991. So that also means, so that's a different way to decide if you want to reject. So do you like that method?
Yes.
You do like that method? Okay. So you're welcome to do that. In either case, whether I'm looking at my p-value, which was 0.0003, okay, I'm still going to reject it. So it should give you the exact same conclusion, reject the null. So your critical value in this case is 5.991.
Yes. Yes.
Okay.
So, but your p-value. So are you saying if your p-value is less than your alpha, then you reject it?
If your p-value is less than alpha, then reject. Yes, that's true.
Okay, that's what we did.
Okay. Yeah, that rule hasn't changed. If the p-value is low, reject the null. Okay? Go ahead, Sydney.
So if we were trying to find the p-value
on the chart, that's where I was just going next. Okay, so how do you find the p-value based on the chart? Okay? That's the real question, right? That's the question that's going to be on the quiz today. Okay? So I'm looking at 2 degrees of freedom. Where does 16 fit on there? It's beyond this 10, right? So what would my p-value be in this case? It's less than 0.0005, and in fact, it's 0.0003, so it is less than.
There's 2 zeros on that, not 3.
Oh, there's only 2, sorry. Correct. Okay, less than 0.005, and I'm a lot less than 0.005.
So you're always going to get out the row of the grid.
Yeah, now let's do another one. Let's pretend, for example, on 2 degrees of freedom that I got a value of 6. So my sum equals 6, okay? And I've got degrees of freedom equal to 2, okay? So what would you do in this case? So we're looking at this line. Where does 6 fit on that line? It's in between those 2 values here, right? So it's in between these 2 values here. So your p-value is in between 0.025 and 0.05, okay? Because as we look at here, on this line here, 6 fits right in between there. Does that make sense? And so that's what you would write on your paper. Now, given that alpha is 0.05, would I reject or would I not reject? Okay, so my p-value is in between 0.025 and 0.05. My alpha is 0.05. Okay, let's do a raise of hands. Who says reject? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who says do not reject? 1? You're overruled. Yeah, reject is correct. Reject. Okay, because it says it's less than 0.05, so it's got to be less than 0.05. Does that make sense, Gabrielle? Okay. Should we do one more, just to make sure you can find your p-value? Let's find the p-value. The value is 10. The sum of my chi, so chi-squared sum equals 10. And I have degrees of freedom equal to 13. Find your p-value with the chart. It's going to be in between 2 numbers, right? Okay. So I'm looking at line 13, right? 13 degrees of freedom. Where does 10 fit on that line? Fits right in between here, right? So what's my p-value? It's in between 0.10 and 0.90. That's a big range, right? Sorry, that's all you get. Okay, would you like to find out what your p-value really was? Only way you can do that is with a computer. Oh, I wasn't sharing again, dang it. Keep forgetting to share. Okay, so you're looking at here, you're right here, okay? So if my p-value equals chi-square right-tailed, I said it was 6 with 13 degrees of freedom. That gives me a value of 0.94. Wait a second, that shouldn't be right. Didn't I say 6? Oh, I said 10. Sorry. 10. 0.69. Okay, so 0.69 is in between 0.10 and 0.90. Okay, so given this here, let me share or do that. Given these values here, my alpha is still 0.05. Would I reject or would I not reject? What? Do not reject. Okay? Are you good? You ready for your quiz? Okay. All righty. Let's pass out the quiz.